Alrighty, the previous recording didn't work, so we're going to start again. Let me restart my timer. So this paper by Weaver et al. 2021 basically took 12 sheep and subjected half of them to a saline solution as a control and the other half to cortisol injections. And those cortisol injections were trying to mimic activation of the HPA axis and the activity and what these hormones would do if an animal were stressed. They also attempted to look at the non-blood methods of understanding the HPA axis activity. So we looked at, instead of looking at plasma directly, or specifically rather, we looked at saliva, urine, feces, and wool. So just a bit of background on the literature. Blood plasma is by far the most commonly used method of cortisol analysis and hormone analysis. It's critical to understand activity of the HPA axis so that we can pinpoint and remedy stresses, so that if you take one sample, for instance, we can not really understand much about that. But if we were to take multiple samples, then we can. That's sort of the third point there that I think is best described by, if you were to take a video is just a collection of images sped up quite quickly that tells a story. Whereas if you're just taking one sample, one blood sample, for instance, that's not going to tell you much compared to samples collected over an extended time frame. The findings of this paper include that wool cortisol was higher in cortisol-treated use, so almost double that of the saline control, meaning that cortisol is deposited into the wool. Cortisol peaked in wool more slowly and compared to the plasma, which means that, and it declined more slowly. So the fact that it takes longer for cortisol to get into wool and declines more slowly means it's a long-term, it's viable as a long-term accurate biomarker of chronic stress, because it means that you can assess stresses that happened potentially months, maybe multiple months, even years ago, if you have wool that's long enough. Just a point at the end there that they mentioned that you can potentially understand or quantify the growth rate of wool. If you can do that, then you can understand at what times or how long ago these cortisol peaked, and then you could potentially identify the stresses and remedy them. How is this related to my project? Well, it directly proves that wool is a reliable and comparable method of cortisol assessment compared to the other typical methods, blood being the chief one there. Elevated cortisol levels also decrease wool growth, which I'll get into in future papers. And I think the main, one of the most important facts so far is that wool is a long-term store of cortisol. It provides a longer-term window of HPA axis activity compared to feces and saliva, and urine, and mostly blood, which provides a sort of a short-term snapshot.